Hello everybody, hope you're doing well. This is May 2025, paper 1, and this is time zone 1. Let's have a look and see what we can do. Here we go, question 1, 6-mark question. Hot air balloons are available in many sizes for different numbers of passengers. The following table shows the recommended minimum volume of a hot air balloon in cubic meters for a specific number of passengers. And then we have number of passengers, which is our x, and recommended minimum volume y. A table here listing the number of passengers and the corresponding volume of the balloon in each of these cases. Here's part A. Use your graphic display calculator to find Pearson's product moment correlation coefficient R for these values. So asking us, what is the relationship between the number of passengers and the volume? What is the strength of that correlation? And to solve this, we're going to need to go to the calculator. So let's go ahead to the calculator. Let's open up spreadsheets, label our variables, x and y, and then we'll just input these values fairly quickly, I suppose. And corresponding volumes. And we are just about done. I think sometimes on a timed exam, it's not a bad idea to check these really quickly because it would be an unfortunate way to lose marks. All right, these look good. Let's go ahead and find Pearson's correlation coefficient. Let's go menu, statistics, stat calculations, two variable statistics. We're relating two variables to one another. Where did we put our x's and the x and the y's and the y's? That's all we need. Let's go ahead and look for R. Here we are. So R is 0.998887. 3 sig figs, that would be 0.999. So really strong correlation. Let's go back to the document and let's write this out. Here we are. This is R. R is equal to 0.999. Okay. Part B, and then number 1 of B. Find the equation of the regression line y on x for this data in the form of y equals ax plus b. And then part 2 asks us, we can read this as well, state what the value of a means in the context of the question. So we've got an equation of a line. We want to find the line of best fit essentially right here. In standard slope-intercept form, we usually call this y equals mx plus b, but what is in front of our x is just our slope. And they're asking us, okay, what does this mean in a real-world context? One important thing, I hope this isn't too long, but one important thing to remember is both of these questions together are worth 2 marks. So it's asking for a fair bit, but we should, I guess, be mindful of time constraints as well. So find the regression line. That's going to lead us to go back to the calculator here. So let's actually go ahead and do that. Go back to the calculator, find our regression line. We still have this 2 variable statistics. This isn't a regression. So I'm actually going to Control Z and get rid of this. And now we can go ahead and run a linear regression. Menu statistics, stat calculation, linear regression, y equals mx plus b. Standard form, this will work. Here we are. Where did we put our variables, x and y in their respective columns? And here we go. So here's our regression line in the form of y equals mx plus b, m our slope, b is our y-intercept. In the question they gave us ax plus b, but just remember anything in front of the x is our slope. It's how much we go up by or down by for every x, for every change in x. So let's go back, actually let's read these values first. M is 340.38, B is 742.016. 3 significant figures, this would be 340, and 3 significant figures, this would be 742. So let's go back to the document. All right, so y is equal to m, our slope, which was 340x, plus b, our y-intercept, 742. Okay, actually we should say that's B1. Second question for part B right here. They're asking us state what the value of A means in the context of the question. So we know that A, what we usually call M, is our slope. It's a rate of change. So change in y over change in x is what we usually say when we're talking about a slope. Change in y over change in x, or the slope formula y2 minus y1 over x2 minus x1. How much do we go up by for every single move to the right? I hope this isn't, again, too long, but here it is essentially. So this is volume and this is passengers. So what does this mean? As we increase the number of passengers, we need to increase the volume. So essentially, for every one passenger, what is the increase of volume? Well, we need to increase by 340 cubic meters for every single passenger that we take on board, I suppose. So what is that? How could we write that out in the context of this question? What does it mean? It means that the balloon volume increases. That's a little messy. Increases by 340 meters cubed for every additional passenger. There it is. Kind of long for just 1 mark. I'll show you what the mark scheme says right here. Here it is. The recommended minimum volume of the hot air balloon increases by approximately 340 meter cubed for each additional passenger. So pretty much the same, quite a bit for just 1 mark. Okay, let's go back to the document. Part C. Use your regression equation from part B1 to find the recommended minimum volume of a balloon for 10 passengers. So we have a set of passengers here. We don't actually know how much 10 passengers would be. If we actually didn't find the regression, we can test to see is our value actually between this range, just to give us a kind of, we call this like a sanity check in some ways. So let's actually look at our regression equation, and then this is actually an input-output question. So we just need to input a value of 10 passengers, and then find the output, the volume. So y is equal to 340. In this case, x is 10. We have 10 passengers, and then plus 742. This is going to be 3,400 plus 742, 4,142 cubic meters. You can work that on the calculator, and it would take you to the same value. What is this, 4,142? You'd be fine writing that to 3 significant figures once again. This would be 5140 meters cubed. All right. 6-mark question, fairly straightforward, but I guess just gotta manage time. Okay, let's go to question 2. A car manufacturer collected data about preferred car color from drivers in various age groups. The results are presented in the following table. Now we have age groups into different class intervals, and then we have preferred car color in each of these cases, and then we have the totals for each. Part A asks us to write down the value of B. So looking at the graph, here's B. And how can we work this out? Well, we have totals for our columns and totals for our rows. So we know all of these must add up to 58. All of these must add up to 46. So I think this is going to be easier just because there's fewer numbers. So if we wanted to write an equation, we could say this: 7 plus B plus 18 equals 46. We could end solve that if we wanted, but I'm going to work this out. 18 plus 7 is 25. 46 minus 25 would take us to 21. And then we can double check. 21, 28, 46. That looks good. Okay, so B is equal to 21. Just a 1-mark question, actually. So maybe just to clarify, you don't actually need this. All you need is the answer. Write down is just expecting an answer. Okay. The car manufacturer performs a chi-squared test for independence at the 1% significance level to determine if there is significant evidence that different age groups have different car color preferences. The null hypothesis and alternative hypothesis are defined as the null hypothesis. Age and car color preference are independent, or the alternative, age and car color preference are not independent. The chi-squared critical value for the test is 16.81, and then part B asks us to find the chi-squared test statistic, and then C, write down the conclusion of the test in context, give a reason for your answer. All right, so standard kind of chi-squared independence test. Remember, we have two chi-squared tests, independence and goodness of fit. This is a standard independence test. We can either have a p-value or chi-squared test statistic, so just be careful not to mix those up. But otherwise, let's go ahead and input these values into a table. We'll get a matrix set up, and then we'll work this out on the calculator, find our chi-squared test statistic. I think that should be good. I'm actually going to put this 21 here because we're going to need it. Okay, so heading back to the calculator here, let's go menu, let's go into the calculator, and here we want to set up a matrix. So we're going to go menu, matrix and vector, and we're going to create a matrix. In this case, actually just going back to the document for a sec, we have a table that has 1, 2, 3, 4 columns and 3 rows. Remember, we don't include the totals, just the values themselves. So 4 columns, 3 rows. Back to the calculator. 3 rows, 4 columns, not including tables. 12, 7, 4, 17. I'm just going to input these really quick. 15, that's the 21 that we found. 10, 12. And then just working on here. 16 and 6. All right, now we need to define our matrix. Let's go control var, and we'll define it as A. Call it whatever you want, really. There it is. Let's make sure we actually defined it. There it is. Okay. Now let's run a chi-squared test. So we'll go statistics. We'll run stat tests. In this case, we want to, where is our chi-squared two-way test. So we don't want to run a goodness of fit. We want to run a two-way test. All right, the observed matrix, we called it A. It's the only one that should be available. There it is. And here we go. Here's our chi-squared test statistic, and there's our p-value. I think they're only asking for the chi-squared test statistics, but these things are related. I'm sure there's other videos out there that kind of explain these, but just to go again really quick, p-value, the probability that we're going to see these kind of results just based on chance alone, and the chi-squared test statistic is the measure of difference between the observed, what we would observe just based on chance alone, and then, what we observe, and then what we would expect just based on chance alone. So this is measure of difference between observed and expected, and this is the probability that we would see these kind of results just based on chance alone. So p-value, it's pretty small actually, so pretty unlikely we see these results, which tells us that, there might actually be some kind of relationship between these variables, because this is a little different than what we would expect just based on randomness alone. All right, chi-squared test statistic 18.32, 3 significant figures. Let's go back to the document and write that out. Here it is. B chi, looks like an x. How can we write a chi-squared without, well, chi-squared, my oh my. Chi-squared is equal to 18.3. Okay, so our chi-squared test statistic is larger than our critical value. So we're going to need that for part C. Write down the conclusion of the test in context. Give a reason for your answer. Okay. So comparing our chi-squared critical value to the chi-squared test statistic that we found. So let's write this out. Chi-squared crit is less than our chi-squared test value that we found. So what does that mean? That means that, well, 16.81 is less than 18.3. In a real-world context, or I mean just explaining this statistic a little more, it means the difference between the observed and the expected is greater than what we're willing to tolerate. This is how much difference between the observed and the expected we're willing to tolerate. We have more than we're willing to tolerate, greater difference, which means that, well, we reject this idea that the car color preferences are independent, because it looks like they're actually influencing one another, or there's some kind of relationship between them in some kind of way. So what would we do? We would reject. Reject, or I guess a little more kind of technically proper, we would fail to accept. We fail to accept. Fail to accept null hypothesis. Write down the conclusion to the test in context. Age and car color preference are not independent. Essentially, it's the alternative. I guess we could write that down. Fail to accept null hypothesis, which means we're left with the alternative. And that means that age and car color preference are not independent. All right. Okay, I think that's good. Maybe I'll just say one more thing. The p-value that we found, because sometimes some students, maybe it is, how do you distinguish between the chi-squared and the p-value? Because sometimes they ask for one, ask us to draw a comparison with one versus the other. The p-value in this case was approximately 0.0055, I guess. And that's pretty small. As a percentage, that's only 0.5%. And there's this kind of helpful kind of mnemonic memory tool that says if p is low, the null has got to go. So if the p-value is lower than your critical value, then it has to go. And they actually told us that p crit was equal to 1%. So you can always use both. You can use the p-value, or you could use chi-squared. They're just what we'd say inverted. If p is low, the null has got to go. In this case, the p-value is less than p crit, so the null has got to go. In this case, measure of difference, our chi-squared test value, there's more difference than we're willing to tolerate. Again, the null has got to go. Okay, let's move on. Okay. This, I think, is actually kind of a tricky question. It's one of those questions that is, I suppose, a little more rare. It's a system of equations questions that don't see too often. I think it's a fair question, but not one that you see very often. Okay, let's have a look. 5-mark question. A bakery sells boxes of cupcakes at the following prices. A small box containing 1 cupcake costs $4.50. A medium box containing 6 cupcakes costs $23.50. A large box containing 12 cupcakes costs $44.75. And there's our medium box. They included a picture. All right. In a particular week, the bakery sold 88 boxes containing a total of 383 cupcakes. The bakery collected $1,486 from cupcake sales for the week. The number of boxes of cupcakes sold during the week can be represented by x plus y plus z equals 88. And I think they told us, here we are, where x is the number of small boxes sold, y is the number of medium boxes sold, and z is the number of large boxes. All right, so x plus y plus z, total number of boxes equals to 88. And then we have a number of different relationships up here. There's 88 boxes sold, we know that, 383 cupcakes sold, total amount of money that this shop has made, and then the price for each of the size of boxes. Part A, write down an equation in terms of x, y, z to represent the number of cupcakes sold during the week. All right, so we know we sold 88 boxes and we sold 383 cupcakes. Okay, so let's go and write this out. So we know we're going to have something equal to 383 because that is the number of cupcakes sold during the week. So let's write that out. 383. I guess we could actually write it in terms of variables first. I don't know if it makes too much of a difference. Maybe actually we will. Okay, let's write it in terms of this x, y, and z. So x is a small box, y was a medium box, and z was a big box. So if we sell one small box, we sell x number of cupcakes. And if we sell a medium box, well, in each medium box there are 6 cupcakes. So for every medium box we sell 6 cupcakes. That is to say, if y is equal to 1, we sell 6 cupcakes. If y is equal to 2, we sell 12 cupcakes, and so on. Similarly, a large box contains 12 cupcakes, so for every large box, we sell 12 cupcakes. And then this is equal to, I think it was 383, if I'm not mistaken. All right, and there is our equation. Let's put that down. Not a lot of space here. It's fine. Okay, so part A1, what is a relationship in terms of x, y, and z that represents the total number of cupcakes sold? Well, x plus 6y plus 12z equals 383. 383 total number of cupcakes sold. All right, let's look at part 2. The money collected from sales of cupcakes for the week. Okay, so an equation in terms of x, y, z, and this is the money collected from sales of cupcakes for the week. Okay, so I think they told us they made 1,486. So let's go up here and use this template. So we have $1,486 that are made. And how is that formed? Well, we know we make $4.50 for every small box. We make $23.50 for every medium-sized box. Whoops. And we make, there's enough room here. We make $44.75 for every large box. For every large box. It's a little squished, but that's fine. Okay, and this would be our total amount. So let me just copy this again. Bring it down here. Okay. So here is our equation. $14.86. Just wanted to clean that up a little. To explain it once again, $4.50 for every small box, $23.50 for every medium box, and $44.75 for every large box, totaling $14.86. All right, and last part of a systems of equations question. They're gonna, I think, ask us to solve for x, y, and z. Hence, use your graphic display calculator to determine the number of medium boxes that were sold during the week. So we just need to find the value of y. Okay, so we have a set of linear equations. We have one equation, 2 equations. For this situation where we have 3 variables, we're going to need 3 equations for 3 unknowns. So we're going to need to find one other equation here. Let's actually look through this. Let's see what we've used and and what we haven't yet. And it's kind of like just what can you say? Not like sneakily, but it's right in front of us in a way. So we have the total number of cupcakes. We have total earnings. And then we actually haven't used this. Here's another equation in terms of x, y, and z, the total number of boxes. So we actually have our third equation right here. This is our third equation, x plus y plus z equals 88. And now we have 3 equations for 3 unknowns. So we can actually go ahead and solve this. So let's go ahead and go back to the calculator. Okay. In this case, we are going to go back to algebra In this case, we want to solve a system of linear equations. How many equations? 3 equations. This will populate z, and now we can just put these in. This is the first one they gave us. They gave us x plus y plus z equals 88. And then we have x plus 6y plus 12z. That was the total number of cupcakes. And then we have the total earnings, 450x plus 2350y plus 4475z equals, and then the total amount was 1486. Just going to check these once again. Looks good. 450, 2350, and 4475z, 1486. This looks good. All right. And that's kind of reassuring. So we sold 53 small boxes. We sold 15 medium boxes and 20 large boxes. Okay, let's go back to the document, part B. And so y, or the price of a medium box, is equal to $15. We can actually write that out. Oh no, not $15. We sold 15 boxes, jeez. Okay. All right. I guess we could just say one thing. If they're asking for a number of boxes and we run a system of equations to solve for x, y, and z, we would want these to be whole number value solutions. That is to say, no decimals, no fractions, and no negative values. So this is good. It kind of confirms what we would expect. Okay, let's go on to question 4. All right. A swimming pool has a shallow end where the depth of water is 1.2 meters and a deep end where the depth of water is 2 meters. A cross-section of the water in the swimming pool with additional dimensions is shown in the diagram. Okay, so here's a shallow end, deep end, we have the slope floor right here, and the total length of the pool, and so on. A safety regulation states that the gradient of the sloped floor of the swimming pool, as shown in the cross-section, must not be greater than 1/3. So the gradient in this case cannot be greater than 1/3. Show that the swimming pool satisfies the safety regulation. Okay. So what is gradient? Gradient is m, it's the slope, and that is this value right here. So let's actually just maybe make a little sketch, see what we can do. Oops. Bring that up here and draw this out. So here is a gradient. There's change in x, and then let's draw change in y. Okay. So in this case, what is our change in y? Change in y is equal to, well, if this is 1.2 and this is 2, 0, that means the difference between these is actually 0.8. So 2 minus 1.2 gives us 0.8. So we go down by 0.8 meters over what kind of distance here? And if this whole pool is 7.5 meters long, and this is 3, and this is 1.8, what is this missing piece right here, which completes the total length of the pool? 3 plus 1.8 is 4.8. 4.8 plus 2.7 would give us that 7.5 that we're looking for. Okay, I think that looks good. 5.7, yeah, looks good. So we have change in x and change in y. Remember, for slope m, this is in your formula booklet, we have change in y over change in x. And in this case, we went up by, if we're moving to the right, we went up by 0.8 for a, I guess, horizontal distance of 2.7. So what is that? Is it less or is it more than 1/3? You can see it's actually less because 1/3 of 2.6 is 0.8. So this is slightly less. But let's actually go to the calculator and work this out. So let's go menu. Oops, no, we don't need that. Let's go and get a fraction. 0.8 over 2.7, and we see this is 0.296. So as a decimal, we could say this is 0.296. And if we wanted to, we could write this out as a fraction. Okay, so this is less than 1/3. 1/3 being 0.33333, and so on. So, show that the swimming pool satisfies the safety regulation, we could say that 0.296, or even better actually, we could say that 8/27 is less than 1/3. And maybe I'll show this. So what could we do? We see that 3 and 27 are actually related to each other. So if we multiply, what do we need to multiply 3 by to get to 27? Well, we need to multiply it by 9. And if we do that to the top and the bottom, then we can write an equivalent statement that says 8 over 27 is less than 9 over 27. And yeah, things are satisfied. Okay. The time to fill the pool with water is inversely proportional to the water flow rate in liters per minute of the hose being used. A hose with a water flow rate of 300 liters per minute will completely fill this pool from empty in 4.5 hours if the hose is run continuously. Determine the time it takes to completely fill the pool from empty using a hose run continuously with a water flow rate of 170 liters per minute. Okay. So they give us some information here. If you want, you can kind of categorize this question as a proportional question. They're talking about an inverse proportional relationship here. But sometimes it's easier to actually think about this intuitively. And I think actually this question is easier to look at intuitively. So what are they telling us? I'll work it out through intuition, and then I'll kind of work it out using a standard kind of formulaic procedural way. So let's work it out through intuition first. So we have this hose, and it's filling this pool at a rate of 300 liters every minute, and it takes 4.5 hours to fill up this pool. So let's actually just work this out. This is in minutes, this is in hours. So 4.5 hours, times 60, 6, 12, 24, that would be 270 minutes. So this hose is running for 270 minutes, and every single minute it contributes 300 liters to this pool. And so we already can find out how much volume this pool has, because, well, 270 minutes this hose is running. It runs for 300 minutes. We can work this out on the calculator. 5481, I think. This is 81, and let's add our zeros, 1, 2, 3, 81,000. 81,000, is that correct? Or is it 2, 4, yeah, it's correct. 81,000 liters. So just to kind of summarize what we did again. We have this hose running for 4.5 hours. 4.5 hours, there's 60 minutes in every hour. We have this hose running for 270 minutes. Every single minute, 300 liters are put into this pool. So 300 liters every single minute for 270 minutes. That leaves us with 81,000 liters over this whole amount of time. And so if we want to determine the time it takes to completely fill the pool from empty using a hose that has a flow rate of 170 liters per minute, well, we know how big this pool is. It's 81,000 liters. And we know how fast, or the rate at which we can fill this pool with a small hose. And so in this case, we have, well, 81,000 liters, and we can fill this pool at a rate of 170 liters per minute. And in this case, we've got an equation. So 170 liters per minute, we need to fill a total of 81,000. How many minutes fit into this large volume? Let's work it out on the calculator. 81,000 divided by 170 That's not that helpful. Let's go to numerical solvents. Let's approximate to decimal. 476 minutes. 476 minutes, 0.471. It doesn't say if they're asking us for minutes or hours. So I'm going to write 476 minutes. And then if we wanted to, we can just divide this by 60. And we can find that it will take us 7 hours. So I'm actually just going to write this out. It's going to take us 7 hours. And then we're going to have this 0.94118 that we haven't yet accounted for. So I'm going to subtract by 7. So we already took care of this 7 hours, but now we have 0.941176 of an hour left. You know, in 1 hour there's 60 minutes. So we also have 7 hours right here, and then this 94% of an hour left. What's 94% of an hour? Well, roughly 56 minutes. 56 minutes or so. 7 hours and 56 minutes. So going back to the document here. Okay, so there we are. Not too bad, I don't think. So what was the kind of like standard procedural formulaic way to go about this? If you want, right? It's helpful in some ways, but potentially not as interesting, I guess. Here's the standard kind of procedural formulaic way to go about this. We have two kinds of relationships. We have y is proportional to x. This is just direct proportion. Or we have an inverse proportional relationship where y is proportional to, well, the inverse of x. So we have k divided by x. And that's what we have here. We have an inverse. That's to say, an increase of one thing leads to a decrease in the other. An increase in the flow rate leads to a decrease in the amount of time it takes. Whereas a direct proportional relationship would be, what would it be? It'd be like if you had a greater number of workers, you could, or bricklayers, for example, you could lay a greater number of bricks over a period of time. Inverse relationship, you have a greater number of bricklayers, the amount of time it takes you to complete the project is decreased as you increase the bricklayers. So in this case, we've got an inverse relationship. Increase the flow rate, you decrease the time. Okay, so actually, let me just fix this. Y is proportional to x, and y is proportional to 1 over x. Okay, so here we are. We're dealing with an inverse relationship, and we have y is equal to k over x. So we're trying to find this proportionality constant. We know what y and x is. Well, y is the amount of time, and, y is the total amount of, y is the amount of time, and our flow rate is x. So let's do this. They're still not in the correct, they need to line these up. So that's not that much different. We need to make sure these are on speaking terms. This is hours, this is minutes. We need to make sure they're both in minutes or both in hours. I think it's going to be easy if we put them in minutes. So let's use this. 4.5 hours is 270 minutes. 270 is equal to k over 300. Let's multiply this. What is k? So you can end solve this, or we can just multiply both sides by 300. And k is going to give us 81,000 once again. And now we have an equation. Since we found out what k is, we know that y is equal to 81,000 over x being our flow rate. So if we want to find the time, well, we're going to need to take, our value of k and then divide it by our new flow rate of 170. That's exactly what we had here. I'm not sure if that's easier. I don't think it is in this case. Okay. Brief summary once again. Yeah, potentially. Direct relationship, increase of one leads to an increase of the other, or a decrease in one leads to a decrease in the other. They're directly related. Inverse relationship says an increase of one thing leads to a decrease in the other. That's what we have here. Increase of the flow rate leads to a decrease of time. So we know they're proportionally related. What is this k value, this proportionality constant? We've set up an equation with 1, 2, 3 unknowns. We know 2 of these unknowns. That's to say we know the flow rate and we know the time taken. So this is the time taken. This is the flow rate. We know 2 out of these 3 unknowns. 2 out of 3 unknowns, we can then solve for that final unknown. We can use nsolve for this. We get a value of k. Now we've got an equation linking flow rate and time. We know what the flow rate is. Now we have, well, we know 2 out of the 3 unknowns. We can solve for this last unknown. I think that's maybe a little more complicated, potentially in this case. If the questions are more challenging, then we might actually need to use this kind of method. But for this, I think intuition works well. All right, let's do question number 5. Okay, here we go. Wait for that plane to pass by. Okay. Here we go. A dolphin jumps out of water. The path of its jump can be modeled by a quadratic function using the following variables. D is the horizontal distance from the point where the dolphin leaves the water. H is the height of the dolphin above the surface of the water. All distances are measured in meters from the point where the dolphin leaves the water. The diagram is not to scale. Tempted to... Okay, all right. Here we go. On a particular jump, the dolphin first reaches a height of 5.1 meters above the surface of the water when the horizontal distance is 3 meters, and again when the horizontal distance is 8.5 meters. Write down the equation of the axis of symmetry of the quadratic function. Okay, that's actually an interesting question. So what are they telling us here? The dolphin reaches a height of 5.1 meters, and that's not the vertex, that's not at its highest point, because there are 2 points when the dolphin reaches this. Once at 3 meters and once at 8.5. So I'm just going to estimate where these might actually be. So at 3 meters, let's imagine this is 3 meters. And let's imagine this is 8.5. And let's try to kind of illustrate this, maybe just slightly. At this point of 5.1 meters, let's say this right here. So let's say this is 5.1 meters. 5.1 meters. There are 2 points at which this dolphin has a height of 5.1 meters. One's here, when it's 3 meters from its, the point where it broke the surface of the water, and then 8.5 meters away. Okay, so they're asking us the equation of the axis of symmetry. An equation means we're going to need an equal sign. The axis of symmetry is the line through which, we could say the mirror line of the quadratic, or the line that, you could say the dividing line of our quadratic, the highest point, the axis of symmetry. What can we say? There's symmetry in a quadratic. We know that, for example, this is going to be the axis of symmetry right here. Move this up just a little. This value where x is equal to something, this dividing line, this mirror line right here. What is its position? Well, these are going to be equally spread apart. What could we say? The difference between 3 and 8.5, well, they're separated by 5.5 meters. 5.5 meters separates them. That means, well, the halfway point between would be 2.25 to the left and 2.25 to the right. So just to try to explain that a little more, we have this point at which the dolphin is 5.1 meters above, and then there's another point where it's 5.1 meters above. They told us the first point is 3 meters from the launch, and then 8.5 meters again. We know there's some symmetry here. The total difference between 3 and 8.5 is 5.5 meters. And, well, 5.5 meters is the total difference. And if both of these are equal, then we know we're going to be dividing this 5.5 into 2 equal halves. And that's 2.25 here, 2.25 here. So we can walk 2.25 to the left, or we can go 2.25 to the left or 2.25 to the right to find this axis of symmetry. I think it's easier to start from this 3 value right here. So 5.25 would be the axis of symmetry. Okay, hope that's okay. All right, let's keep going on. The quadratic function that models the dolphin's jump is hd equals negative 0, h of d, so height is a function of distance, is equal to negative 0.2d squared plus bd, where d is greater than 0 and b is a constant. Calculate the value of b. All right. So kind of interesting question. We have one unknown, this b. The distance is, well, the horizontal distance, and height is, well, the height of the dolphin at that point. Calculate the value of b. So what do we have? I'm going to write this out right here, not in function notation, but just as an equation. So height is equal to negative 0.2d squared plus bd. So what we have here is an unknown, this b value right here, but there are given values. We know, for example, that when the dolphin is 8.5 meters from where it broke the surface, it's at a height of 5.1 meters in the air. Similarly, a distance of 3 meters in terms of horizontal distance traveled of this dolphin means that it is 5.1 meters in terms of the vertical distance. So we have a d and we have an h, or more common and more familiar, we have an x and a y value in some sense. We know a horizontal point and we know a vertical point. We have a value for d and h. We have a point that lies on the function. So in that case, we should be able to substitute these values. Again, we have 1, 2, 3 unknowns, but we have 2 out of the 3 unknowns here. So we should be able to just solve, substitute and solve. All right. The height is 5.1 meters when we are 3 meters from the point at which, I guess, broke surface. And then d is once again 3. So we have 3 unknowns, but we know 2 out of the 3. We can solve for that last one just through substitution. So I'm going to go to the calculator here and work this out. Let's go menu. In this case, we want to go algebra, and we can just write numerical solve. So 5.1 equals negative, should we use this negative right here? Negative 0.2, and then we will negative 0.2, b we don't know yet, and then there we are. 3 is again the horizontal distance. Okay, let's make sure that's correct. This is its height, this is the horizontal distance, and then b is what we are trying to solve for. Okay. This is kind of interesting. This sometimes happens. Sometimes the calculator doesn't really like the brackets. So I'm going to copy this and rewrite it. So let's go and write this as a multiplication statement with this little multiply symbol. Okay, let's see if that helps. There it is. Okay, so b, the constant, is equal to 2.3. let's go back to the document and write that out. Calculate the value of b. Oh, I thought the little dog had stopped. Okay. Okay. Part C, find the horizontal distance when the dolphin re-enters the water. Okay. So here's the dolphin traveling through the air. We know it leaves the water at a position of 0, 0. That is to say, the height is 0 and the horizontal distance it's traveled when it leaves the water is 0. But after going through the air, what is the point at which it re-enters the water? So we have an equation. We have an equation right here linking height to the distance that the dolphin travels. And I'm actually going to write that out right here. So the height that the dolphin travels is related to negative 0.2 d squared. We found out what b was. It's 2.3 d. We have an equation which relates the height of the dolphin to the distance traveled. And the question is, okay, well, how far has it traveled after it hits the water? Well, once it hits the water, it's going to be at a height of 0. This is the surface level of the water. So this is an input-output question. We know the output, that is to say, the height is equal to 0. What is the input that makes that true? So when h is equal to 0, what is d? What is the distance traveled? So let's put that in. 0 is equal to negative 0.2 d squared plus 2.3 d. Remember, this is a quadratic, so it's going to give us two values. It's going to give us this value right here, and this is the one we actually want to find. So let's go to the calculator, and there's going to be two ways to solve this. We could graph it, or we could use nsolve. I'm going to show you nsolve first. Okay. Menu, algebra, numerical solve. I got to see if I remember this function. So let's go negative 0.2 d squared plus 2.3 d. And what this is going to give us is, if it works, I think it will, it's going to give us a value of 0, because nsolve always finds the value that is closest to 0 initially. Too few arguments. I see. There we go. It's going to give us a value of 0. So what nsolve is doing is saying, okay, I will solve this equation for you, and I will start by finding the value that is closest to 0. And that's not too interesting because we know that, well, at a point of distance of 0, the dolphin just breaks the water. So we want to find the other value. So do I remember how to do this? Do I remember how to do this? I think I do. We put a comma, and then we say, okay, well, don't start from 0. Start from 0.1. That is to say, what this comma means, or this little command, I suppose, says, do not just search anything from 0. Start at 0.1 and then search to the right. And there we go. So 11.5. Normal nsolve finds the value that is closest to 0, the d value that is closest to 0. If you put this little function in, it's saying, okay, what is the minimum bound? I will search everything to the right of that. We say, okay, well, I don't want to include 0. Start at 0.1, find everything to the right. Okay, so there it is. After 11.5 meters, the dolphin re-enters the water. Let's go back to the document. So d is equal to 11.5, let's put meters in. Okay, let's go on to part D. Part D is just a 1-mark question. Explain what a negative h value would mean in this context. Okay, well, h is the height above the surface of the water. So this is 5.1, for example. H means the dolphin is 5.1 meters in the air. A negative h value would mean that the dolphin is under the water. So if h is the surface, or the distance above or below the water, positive is above the water, h is when we are under the sea. So let's see. Negative h means below the surface of the water. Surface of the water. I should use CapCut and splice in under the sea. Maybe I will. Okay, negative h means we're below the surface of the water. We're underneath. We're in the water, I suppose. Let's work through this question here. A child's game is played by making paths in the snow. First, 2 circular paths are made using the center O. The radius of the small circle is 2.8 meters, and the radius of the larger circle is 4 meters. Additional paths are then made from O to the outer edge of the larger circle, dividing the path into 5 equal sectors as shown in the following diagram. So we've got the circle, we have the smaller radius, a larger radius, and then we have 5 equal sectors right here. For your calculations, ignore the widths of the paths. Okay, so here's the path, here's the radii. Each region between the paths will be colored with environmentally friendly dye. The shaded region below will be colored orange. Okay, so here it is, coloring this orange. And this is our entrance, I suppose. Maureen has enough orange dye to cover an area of 6 meters squared. Show that Maureen has enough orange dye to cover the shaded region. Okay, so essentially what they're asking us, what is the area of this region? Is it greater or less than 6 meters squared? So what is the domain in which we're in, I suppose? Well, we know we're in the domain of geometry. We're dealing with circles, and we're dealing with parts of circles, that is to say, a sector. This circle is divided up into 5 equal sectors. So what we can do is, well, find the area of this large sector, but we don't want all of it, so let's take away the area of this smaller sector. That should be a nice kind of method that we can use. So let's go ahead and just write some values down. So let's write out this right here. I think this will be okay. I'll write this. So let's call this the area of the total. Area total. And let's call this right here. Let's write this out in red. Let's call this AS. So A total will give the blue. Actually, let's just write it out. I think that's fine like that. And then we'll call AS the area shaded. Okay. And then what can we say? What can we say with the smaller one? Actually, let's change these values to A1 minus A2. All right. Total minus area shaded. Let's actually leave that. Area total, let's call this right here. I was going to say AS for the small sector, but maybe we'll just call it A1. A1. Let's call area A2. Let's do this. This will be better. A1 should be the big one. A2 should be the smaller one. So if we wanted to write an equation, we could do it like this. A1 big area minus the small area, which we called A2, should give us area shaded. I guess it doesn't really matter the subscripts that we use, these little 1, 2, or S, but big area minus the little area will give us the shaded region. Okay. So what is the big area? What is A1? A1 is going to be, in this case we actually have a sector, a portion of a circle. The area of a whole circle is equal to pi r squared, but we don't have a whole circle here. We just have, well, a fifth of a circle. So we can use that actually. That will be fine. So we have 1/5 of a circle, and that will give us area of 1. So just once again, we have this whole circle divided up into 5 equal sectors. So we have 1/5 of the area of a circle. So let's work that out. 1/5 pi r squared, 1/5, in this case, radius is, the radius of the bigger circle is 4. So this is 4 squared. This is going to be 16 over 5 pi. You could use decimals for this, that would be fine as well. Let's find the smaller area, that is to say, A2. Well, what do we have here? We still have, if we're talking about, even this smaller circle is still divided up into 5 equal sections. So we still have 1/5 of a smaller circle. But what's that radius of the smaller circle? It's 2.8. So 2.8 squared. Not sure what that is. 7.84. So 2.8 squared is 7.84. So writing that out, 7.84 over 5 pi. All right, so we have the larger area and we have the smaller area. If we take away the smaller area from the larger area, we'll just be left with the shaded. So let's go ahead and complete this equation that we have set out right here. Okay, A1 is 16 over 5 pi minus A2 is equal to 7.84 over 5 pi, and this will give us the shaded area that we're looking for. Okay, so can we do this? Yeah, I suppose we could. We could write this, I guess. How could we write this? 16 minus 7.84 will give us 8.16. 8.16 pi over 5. That's kind of an awkward way to do it. It is true. Let's go to the calculator and work this out using let's just write it out as a decimal, I suppose. All right. 8.16 pi over 5. Or we could have taken the whole 16 over 5 pi minus 7.84 pi over 5 pi and worked it out that way. So our final answer is 5.127 meters. So what does that mean? Let's go back to the document here. This is equal to 5.127, or 5.127 is 1.3 meters squared. So is she going to have enough die? Yes. Only needs to cover, well, she has enough to cover 6 meters, and this is only 5.13. Show that Maureen has enough die to cover the shaded region. Yes, we know that's true because, well, 6 itself is greater than 5.13. All right, I think that should be okay. 3-mark question, what would they be looking for here? Area sector 1, area sector 2, and then answer. Okay, let's go on. Actually, let's look at the mark scheme. Sometimes it's helpful. Let's see. Here we are. M1. So attempt to calculate area of a circle using 4, 2.7, recognition of multiplication. So we're having a 1/5, and then calculation showing that we have 5.127 is less than 6. Okay. All right, let's go back to the document. I think there's another part to this question. Okay, here we are. During the game, the players start at the entrance and must travel along the paths made in the snow. So here we are. Maureen travels from the entrance along the path shown in the following diagram. Okay. Calculate the distance Maureen travels along this path, starting from the entrance and returning to the entrance. So here's where she goes. She travels along this circumference, along the edge of the circle, and then she goes along here, and then along the edge once again. This is kind of neat. I like this question. So what is this path made up of? What is it composed of? Well, it's composed of these sections right here. There's one section right here. And there's another equal section right here. there's another equal section. So we've got 3 of these equal sections, and then we have, well, the radii. We have 1, 2 of these radii. So if we can find out what these edge-long paths are, what the size of them, or sorry, what the size of these would be, and if we can find out, well, we already know what the radius is, and we have 2 of those, then we can find out the whole distance that she travels. So let's go and find out these points along the edge right here. Okay, so what can we do? What can we do? We can go to the formula booklet for this, but let's just remember a circumference of a circle is equal to pi times diameter, or 2 pi r. Okay, but we don't have the whole circumference. We only have, well, 1, 2, 3 out of the, well, 5 total, I guess, what can we say, sections of circumference we have. So what do we have? We only have 3/5 of a circumference. 1, 2, 3, we're missing these 2. We only have 3/5 of a circumference. So, don't have a whole circumference, we just have 3/5 of a circumference. So that would be this blue edge. And then this right here is just our larger radius. We know above it was equal to 4. So in this case, what is the total distance that she travels of this interior path? Well, this is going to be equal to, well, 2r. 2r, which is going to be equal to 2 times 4. And I should actually clean this up as well and say no. 3/5 of a circumference is equal to 3/5 times 2 pi r. Okay, calculate the distance Maureen travels along this path, starting from the entrance and returning to the entrance. Well, along this path, she must travel through, well, 1, 2, 3 of these edge-long pathways. And then she also must travel through 2 of these radii. So let's work that out. Okay. So what could we say? Could we get path 1, path 2? Let's maybe just write it out like this. 3/5 2 pi r plus 2r. And that would be the total path that she travels. Calculate the distance, maybe let's just call it d. Okay. So what is r? R is equal to, in this case we're talking about the bigger circle in each of these cases. So r in each of these cases would be equal to the 4 we had above. So I'm going to replace the r with the 4. 2 pi r and then 2 times 4 once again. Okay, let's go to the calculator and work this out. Get a new screen. Set up a fraction. 3/5 multiplied by 2 pi r, which is equal to 4, plus 2 times 4. Here we are. Total distance traveled is 23.0796, or 23.1 meters. Distance is equal to 23.1 meters. Okay, another way to work this out would be to look at arc length. So you might say, why didn't we just do arc length? And I think that actually is a decent way. So maybe I'll show that really quick. Really quick. It'll give the same answer, of course. So we have a sector which is a portion, like the slice of the pizza, and then we have the arc length, that is to say the portion of a circumference that we're dealing with. So just like we had the arc length, we could say, just like we had area of a sector, which is equal to pi r squared for the area. We say, okay, well, what angle do we rotate through? That would be some fraction out of 360, knowing that if we rotate through a whole angle of 360, then we rotate through the whole circle. If we just rotate through 180 degrees, we rotate through half a circle, and we have, well, half of the area. In the same way for arc length, let's see, arc length itself would be theta over 360 times, in this case, 2 pi r. So I think this is actually a little more challenging, but if we know this is divided up into, well, 5 equal sections, then we know we have 360 divided by 5, or each of these being 72 degrees. And I suppose you could say this is 72, this is 72, this is 72. And you can say, okay, well, what fraction of the circle do we have? Well, 72 plus 72 plus 72 is 216 over 360, 2 pi r, which would, again, simplify to 3/5, 2 pi r. If we wanted to, we could use arc length. Just like above, we could have used the area of a sector formula as well. It just would have been something like this. Would have been 72 out of 360 pi r squared. That is to say, we have 72 degrees out of a total of 360. And that would have related once again to 1/5. Okay. All right. Question 7. Children inherit genes from their biological parents that determine their eye color. Maria and Alex plan to have 5 children. The probability that a child born to Maria and Alex will have brown eyes is 0.75. It is assumed that a child's eye color is independent of any other child's eye color. Maria and Alex wish to predict how many of their 5 children will have brown eyes. State one criterion in addition to independence that would support them using a binomial distribution to find the probabilities for their prediction. All right, so IB is kind of nice enough in this way to tell us that, yeah, we're dealing with a binomial distribution, but they're also asking, well, what are the conditions for a binomial distribution? Well, one thing is, as they already mentioned, we need to have independence. That is to say, the outcome of one event doesn't influence the outcome of another. So that's one thing we need, and that's already given to us. We need to have a discrete number, that is to say a set number of trials. So they're only going to, or in this case, the plan is to have 5 and only 5 children. They're not going to suddenly extend it to 6 and then 7 and then 8, or in this case, we would imagine, going down to 4 or 3. So we need a set number of trials. Set number of trials, that would be one possibility. So independence, set number of trials, and then we also need constant probability. So probability needs to remain constant. Constant probability. So if either of these are the case, then we can use our binomial distribution. That is to say, fixed number of trials, they're independent, which is already given to us, and the probability is constant. Also, since it is binomial distribution, we need 2 and 2 events only. There are only 2 outcomes. So we can also write that. Only 2 outcomes. So a child can either have brown eyes or they will not have brown eyes. Okay, so let's go on to part B. Calculate the probability that exactly 3 of the 5 children will have brown eyes, and then B2 is at least 4 of the 5 children will have brown eyes. So it's actually a pretty nice question for 4 marks, especially since they already kind of told us that we're dealing with binomial distributions. So let's go to the calculator here and work this out. So calculator, that looks a little funny. I'm going to go back and see. There we go. So let's go menu. We're in the realm of probability and we're looking at distributions. We have a binomial distribution. So in this case, we want exactly 3 of the 5 children to have brown eyes. We can either use PDF or CDF in this case. Let's use, I always like CDF just because it's constant, and just because we don't use normal PDF, we only use normal CDF, and this helps, I guess, prevent any confusion, because we never use normal PDF in the applications interpretation. It's always CDF. talking about a range. So I think, yeah, just to keep it constant, I'm going to use CDF, even though maybe it's a little unorthodox. Number of trials. Number of trials is 5. There's only 5 children. Probability of success. In this case, we want brown eyes. We want to find the probability that a child will have brown eyes, so we're calling brown eyes a success. So 75%. And we want to find exactly 3 of the 5 children will have brown eyes. That means lower bound and upper bound are the same, since we're using CDF here. All right, there we go. So the probability that exactly 3 of the 5 children will have brown eyes is roughly 26%, or 0.263672. So I'm going to go back to the document here and write that out. B1, show a little process. Here we are. Binomial CDF. You can write calculator notation on the exam. The IB does accept that. 0.75, and then in this case, 3, 3. Okay, let's go on. If you wanted to write it more formally, we need to write our value, which was 0.26. And then to 3 sig figs, this would be 264. If we wanted to write this more formally, I suppose, we could say x, some variable x, is distributed binomially. And then we have number of trials and probability of success. And then we could say the p, or what is probability, and then 0.264. Okay, let's go on to part 2. At least 4 of the 5 children will have brown eyes. All right, so now we have a minimum and we can have a maximum. So we can have either 4 or 5 children having brown eyes. But we have the inclusive, at least 4. So here we are on the calculator, probability distributions, binomial CDF. Once again, number of trials is 5, probability of success. Lower bound is 4, upper bound is 5. All right. So in this case, there is a 63% chance, roughly 63% chance, that at least 4 of the 5 children will have brown eyes. Okay, so let's write that out. Binomial CDF 5, 0.75, lower bound, upper bound, and in this case, probability is 0.63, and then 28, so that would be 633. Okay, here we are, part 8. Consider a function of the form f of x is equal to 2x to the negative 2 plus bx to the negative 1 plus c, where b and c are constants. The graph of y equals f of x has a gradient of 0.208 at x is equal to 5. Determine the value of b, and then part b asks us to show that f of x is increasing at x is equal to 3.5. So I might look at this and say, what are they asking? They give us some function here. We don't know what this constant is, this b value right here. We have some variables that are raised to some negative exponents, and then we've got some function and its gradient, that is to say the slope. And they tell us, well, the slope is equal to 0.28 when x is equal to 5. And whenever they give us something like this, that is to say an input and an output, we can say, okay, well, for what function is this true? So we have some input, some x, and we have some slope or the gradient at that point. So what is the function that allows us to put in some input and the output is the slope? Well, that's a derivative. That's the first derivative of some function. So if they give us f of x right here, if they give us f of x and it is 2x to the negative 2 plus bx to the negative 1 plus c, what do we know? We know that f prime, so the derivative, when we substitute in 5, is equal to 0.208. And that might look a little confusing, but all that we're saying is when x is equal to 5, when we substitute that into the derivative, we get this answer of 0.208. That is to say when x is equal to 5, substitute that into our derivative and the slope should be equal to 0.208. And that's the situation where we have 1, 2 things that we know out of 3 unknowns. So if we know 2 out of the 3 things, then we can solve for the final one. So let's go ahead and see what that looks like. So here's f of x. Let's find f prime of x, that is to say, the derivative. So we can go to the formula booklet. Should we go to the formula booklet? If I have it up here, then we can. Really quick. If not, then yeah, here it is. Okay. So let's go to calculus and check it out. F of x is equal to x to the n. That's our normal function. What is the derivative? Well, the derivative, we take this n, bring it down in front, nx, and then we reduce it by 1. And that is our formula that allows us to convert a normal function to its derivative. So let's go back to, that's not it. Did we lose it? This is it, right here. Okay, perfect. So let's go ahead and do that. Here we go, there's the exponent. Let's bring it out, multiply it out in front. 2 times negative 2 gives us negative 4x. The exponent used to be negative 2. Let's take 1 away from that. Now it's negative 3. And now let's do the same here. So we have negative 1 as our exponent. Multiply out in front. Now it's going to be negative 1 times b. So it's going to be negative b. X used to be raised to the negative 1. Take away 1 from that. Now it's negative 2. And then here we just have a c. C is a constant. It raises or decreases our function. It just shifts it up or down, this constant. It doesn't impact the slope at any given point. So it actually just fades away. Constants, remember, we just kind of get rid of when we take the derivative. So the c goes away, and that's helpful because it leaves us with only 3 unknowns. That's to say we have f prime of x, and then we have x, and then we have b. This is the gradient formula. When we put in x into our function right here, we know the gradient, or the slope at that given point, is equal to 0.208. So when we put in x value of 5, the output will equal 0.208. So this is the kind of input-output question that's maybe just requires one additional step. So the slope, or the gradient, when x is equal to 5, is equal to negative 0.208. And when is that slope 0.208? Well, when x is equal to 5. So let's substitute that. So here we go. When x is equal to 5, the derivative is equal to 0.208. And now we've got an equation. We used to have an equation with 3 unknowns. We substituted 2 out of those 3 because we knew them. And now we've just got b to solve for. Let's go back to the calculator and solve this. We can solve this with nsolve. So let's go algebra, numerical solve. 0.208 equals negative 4. Let's open some brackets, raise this to the power of negative 3, minus, and then b we don't know. B is multiplied by 5, and that 5 itself is raised to the power of, I think I actually need these negative signs. This is a minus, a subtract sign. I'm going to write this as negative. I think that might be the case for this one as well. All right. And we want to solve for b. Sometimes the calculator actually doesn't like brackets right beside these numerical values, so I'm not sure if that one's going to work. No, it isn't. So this is going to be something that the calculator is a little confused with. So let's go ahead and modify this. Okay, this is good. This has too many brackets. This, as it is right now, we would raise this whole thing to the power of negative 2, which we don't want to do. We just want to raise this 5 to the negative 2, and we want to have this multiplied. So this looks a little better. Good, and this should work. There it is, negative 6. Okay, so b itself would have to be equal to negative 6 to make this statement true. Let's put that in on the document. So b b is equal to -6. All right. Last part, show that f of x is increasing at x equals 3.5. This is it's kind of a strange question because there's a lot of work to do. And this right here, it's like if you complete all of this, which is an admittedly kind of challenging question, they give you this kind of like cherry on top. It's almost kind of like a gift in some way. Essentially, show that f of x is increasing at x is equal to 3.5. The derivative itself tells us the slope at any given point. So essentially, it's just put in 3.5 into the derivative function. It'll tell you the slope. Is the slope going up? Is it positive? Or is it negative? Is it decreasing? That's essentially what this question is asking. So let's go ahead and write down our complete slope formula, or our derivative. F prime of x is equal to, this is what we had, 4x to the -3. Now we know what b is. That's actually a kind of interesting question. So we have this negative b, right? That was our derivative. We didn't know what it was. So just be careful here. We have negative b, so it's negative, and b itself is -6. So be careful about that. That's a little trick. Or at least an easy way to kind of stumble, I suppose, especially on a timed exam. Okay, so there we are. And now I'm going to write this out just without this double negative. 4x to the -3. Remember, negatives alongside each other, negative times a negative gives us a positive. And then we'll have, let's see. Actually, no, we can't do that. Order of operations says no, we can't. So we have to just keep this as -6. Sorry, this negative out here, because this is connected. So the negative stays out, but still something to be mindful of. Okay, now let's substitute this value of 3.5 into our function and see what the slope is. So f prime of x, we would say f prime of 3.5 if we wanted to. 3.5 to the -3 minus, and then this is going to be -6 to the, -6, geez Louise. So I didn't read this question as well as I should have. It's negative bx, so I got caught up a little. So negative bx to the -2. So in this case we can actually, and we should, deal with this. Let's go ahead and do that. Here we go. Clean it up. F prime of x is equal to -4x to the -3. Negative now suddenly becomes +6x to the -2. That's a little better. Continue to clean this up here. -4, and then x itself is equal to 3.5 plus 6, and then let's put in that 3.5 there as well. Okay, so just to kind of review what we did, here's our derivative. It tells us the slope of a line at a given point, or the gradient at a given point. They're saying, is this function increasing when x is equal to 3.5? Let's just substitute 3.5 into our derivative formula, or derivative equation, and let's see the result. So let's go back to the calculator and see what the value is. So -4 times -3.5 raised to the power of -3 plus 6, open bracket, 3.5 raised to the power of -2. There's a lot going on here with brackets and negatives, so I'm just going to check this over once again. -4, this is applied to, there's no negative here, this is just 3.5, plus 6, 3.5 to the -2. That looks good. Okay, and the answer is 0.3965. What we really need to know is that it's positive, and so it's a positive slope. It's increasing at this point. So let's go back to the document and write this out. All right. So f prime at 3.5 is equal to 0.397. What does that mean? That means we have a positive slope. Or we could just say increasing. Gradient is positive. At x is equal to 3.5. We have our function as increasing. Okay. Let's go on to number 9. Number 9 looks like another kind of algebra question. Let's check it out. So 4-mark question, seems like a short question. Consider the function f of x equals x cubed minus 9x squared plus 23x minus 15 for x is greater than or equal to 0 or less than or equal to 5. The graph of f of x crosses the x-axis when x is equal to 1, x is equal to 5, and x is equal to a. Find the value of a. And the second part is use your graphic display calculator to find the area enclosed by the curve y equals f of x, the x-axis, and when x is greater than or equal to 1 and less than a. Okay, so the first one, let's just find out what the value of a is. Essentially, this is the situation we have. We have some bounds that are given to us. So x is greater than or equal to 0 and less than 5. So we're only really concerning ourselves from this point to this point, and they tell us that it crosses the x-axis when x is equal to 1, when x is equal to 5, and then some other point. So right here, maybe, when x is equal to 1, and then when x is equal to 5, right at the very end of our domain, and then some other point, which, well, I'm not sure where it is, but we can imagine maybe it's something like this. Then it goes off. So we know this, and then where's that other point? Let's go ahead and graph this, and let's find that other point. We could end solve this as well, actually, but I think you're doing this graphically should be okay as well. All right, let's plot the function. This is x cubed minus 9x squared plus 23x minus 15. All right, so there's our function. It's actually not too bad. We don't even need to adjust the window or anything. Let's go menu, and let's analyze the graph, and let's find the zeros. So lower bound, upper bound, so when it's equal to 3. This was the 1, this was the 5, and here we are at 3. When x is equal to 3, we also cross the x-axis. All right, find the value of a. So when x is equal to 2, so find usually means we need to show some kind of process. So what we could do is sketch. I think sketch is going to be the easiest. And actually, using this actually isn't too bad. This sketch over here could make it a little neater. And maybe that's what I'll do. But we're going to need to show some process. X is equal to 2 isn't going to get us the full 2 marks. So a simple sketch should be okay. So here we are. It's x, y. What does the function look like? Crosses through 1, crosses at 3, and then it crosses right at 5. It's increasing at this point right here, then it goes down, and then it goes up. And that should be enough. Okay, good. So that's all you need. Just show the intersection points and a quick sketch. Part B. Use your graphic display calculator to find the area enclosed by the curve y equals f of x and the x-axis when x is greater than or equal to 1 and less than or equal to a. Okay, so here's the x-axis, here's the function, here's 1, and this is a. So these are the bounds, the x-axis, the function, starting at 1 and then going up to when a is equal to 3, a little absent-minded. When x is equal to 3. So what is the area we're looking for? We're looking for this area right here. Okay, so let's find that out. 2-mark question. Let's go to the calculator and work this out. So here we are. We've already drawn this function. Let's go menu, analyze graph, And in this case, we want to find the area under the curve. That's going to be the integral. So what's our lower bound? They told us to start at 1, when x is greater than or equal to 1. Let's put in 1. And what's our upper bound? Our upper bound is equal to 3, right here. And there it is. So the area under the curve is equal to 4. For this, I'm going to go back to the calculator here. Or sorry, back to the document. I'm going to write out the integral. Here we go. So area under the curve starting at 1, going up to 3. For what? For the function x cubed minus 9x squared plus 23x minus 15, and then it's in terms of dx is equal to 4. Okay, that's this little shaded area is equal to 4. That's the area. Okay, not a bad question, I don't think. Okay. Question 10 this is a 7-mark question. A manufacturer designs hats that businesses can order. For an order of 15 hats or fewer, the price per hat is p euros. For larger orders, the price of each hat after the first 15 ordered is reduced by 5 euros. C of n represents the total cost of purchasing n hats from the manufacturer. Part A asks us to write down an expression in terms of p for the total cost of ordering 15 hats. This is just a 1-mark question. So what do we have here? We have the situation where this company, this business is selling hats. You order 1 to 15 hats and you pay p euros for each of those hats. We don't know what the price of an individual hat is, but it's represented as p euros. We'll probably need to solve for this later on. But if we order in bulk for larger orders, if we order more than 15, so 16 and above, the price of each hat is reduced by 5 euros. So to begin, write down an expression in terms of p for the cost of ordering 15 hats. Not 1, 2, 3, 4, 5, 6, just 15 hats and 15 hats only. So let's go part A right here. So if we want to order 15 hats and the price of a single hat is some unknown amount of p euros, well, it's just going to be 15 times p, whatever the price of an individual hat is. So it's just 1 mark, and usually often a good IB question. I think this is a good kind of IB question, a challenging one. Earlier parts lead into the next, so they don't ask you something discreetly and just out of like a kind of curiosity or anything like that, or not in itself, but often it leads into the next. So chances are we're going to need to make use of this. So let's go check out the next question. Write down an equation for C of n in terms of p and n for the total cost of ordering n hats when n is greater than 15. So can we create a function that links cost to the number of hats using these variables p, price per hat, and n, number of hats we've ordered, for an order that is greater than 15? Okay, so what might that look like, and how can we go about doing this? So here's part B. So C of n, the cost as a function of the number of hats we order. So we know if we want to order 1, 2, 3, 4, 5 hats, that is going to just be, well, the number of hats we order times p, the price per hat. There's no special discount or anything. For the first 15 hats, we're just going to have to pay the price of whatever the base is for these hats. So just to order those first 15, we're going to have to pay, well, 15 times whatever the price is. But after this, we get some discount. It's no longer p, but they're going to take away $5. So this is our $5 discount. That's what this is. So this is a $5 discount has been applied. And then what is the number of hats? So if we're dealing with 15 hats, more than 15 hats, then what is n in this case? We can't just write n because we're not buying 15 hats here. The first 15 hats are already contained within this statement right here. So what are we doing? I don't want to just give the answer, actually. So maybe I'm going to write a table here just to try to explain it. And if you want, you can skip ahead and kind of look at the reveal. But I think this will make a little more sense. So here it is. Here is n, number of hats, and here is cost. We buy 1, 2, 3, 4 hats. This is just going to be, well, p. And then 2 hats is 2 times whatever the price is. 3 hats times whatever the price is. 4 hats times whatever the price is. And we keep on going all the way up to 15. And this is just, well, 15p. But what if we want to buy, well, 16 hats, for example? Well, we still need to pay for those first 15 hats. But now we have, well, that additional hat, which is a $5 discount off. So we have one of these. And then, okay, well, what about if we want to buy the 17th hat? Well, we still bought those 15 hats at regular price first. And now we've got 2 of these hats with a discount. You can kind of see where this is going. If we want to buy 18 hats, well, we first bought those 15 at regular price. And now we've got those 3 at a discount, which is the price minus 5. And we can say, okay, so it looks like we need to multiply this binomial right here, this term, by some value. And well, what is that value? It's not just n. It is, let's relate these values right here. So in this case, if we want to buy just one more hat above our base of 15, well, we just have 1 above here. There's a 16th hat. If we buy 17 hats, we're buying, well, 2 above the base. If we're buying 18 hats, we're buying 3 above the base. So in the end, what do we have? We have, well, n, and then whatever the base is. So if this is 16 hats, we want to have, well, subtract the first 15 base hats that we already purchased. So how can we summarize this right here and write this out once again? Cost as a function of the number of hats is equal to the 15 regular priced hats that we have, and then any additional hat is going to be reduced by $5. But that's not for the first hat. It's not just for n number of hats. That's for the 16th hat onwards. So the 16th hat, 16 minus 1, for example, is we're getting 1 hat at a discount. Let's say we bought 25 hats, n is equal to 25. We still paid for this base 15p, but now n is equal to 25. So 25 minus 15, we bought, well, 10 hats at this reduced rate of p minus 5. And I think this helps maybe a little. So it's saying up to 15 base rate, any more, well, we're multiplying. How many hats are we buying at this discount rate? Well, just subtract 15 from n. And that's exactly what we did here. Okay, let's go on to part C. A company decides to order 100 hats. The mean price per hat for this order is $25.73. Calculate the exact total cost of the order. Okay, so total cost is actually, there's 3 marks here for these 2 questions. This is just the 1 mark question. So part C, the exact order. So the average price of 100 hats is €25 and 73 cents. So what is the total cost? Well, if you paid on average 25.73 euros and you bought 100, well, it would just be 100 times whatever the average is. So in this case, it would just be 100 hats times an average price of 25.73, or in the end, this would be 2,573. I guess this would be euros. So let's write that out. Okay, I think that should make sense. I don't really want to go over that too much. The average is just sum of the values over total number of, I guess in this case, units. So if we just times by 100 units, these are going to cancel out and it's just going to give us the sum, the total price. And that's what we paid. Average price of 25.73 times 100 gives us our total price. All right, let's go on to part 2. Hence, determine the value of p correct to 2 decimal places. So not a bad question, but it might be a little difficult or challenging to see where are we going to get that information from? Remember, IB questions often lead into one another, just like this first part led into this. This question right here, the total cost, chances are we're going to need to do something with this. So we know the total cost, and that's this element right here. That is to say, the cost. We know the total cost. We know n, the total number of hats that we ordered, which just leaves p as the unknown. Right now in this function that we found in part B, we have three unknowns: the total cost, the p, price for hats, and then n, total number of hats. We know when n is equal to 100, we spend 2,573. We know 2 out of the 3 unknowns. Let's substitute and solve for p. All right, let's go ahead and do that. So 2,573 equals 15p, don't know what that is yet, plus p minus 5, and n in this case was 100. All right, now we've got an equation and we can actually go ahead and solve this. So let's go to the calculator and do that. At calculator, menu, algebra, numerical solve. Let's write this out. 2573 plus p minus 5. Oops, that's not right. And then we'll multiply this by 100 minus 15 is just going to give us 85. And then let's solve for p. Sometimes the calculator doesn't like these brackets beside a constant or so. It's okay that time. So the price per hat is $29.98. And there we have it. So P is equal to $29.98. And I guess we could, I don't think we'd lose marks for this, but indicate that it's euros. Okay, not a bad question. I think part B was potentially a little challenging on how to work out, but overall okay. All right, question 11, we have a 5-mark question. Mongolia is one of the coldest countries in the world, with the air temperature in winter as low as negative 40 degrees Celsius. It can feel even colder if a wind is blowing. This effect is called the wind chill. On a day when the air temperature is negative 40 degrees Celsius, the approximate wind chill index, W, can be calculated by the equation W equals negative 34.1 minus 7.33 ln V, where V is the wind speed in kilometers per hour, and this is just another representation of kilometers per hour. Part A, find the approximate wind chill index on a day when the air temperature is negative 40 degrees Celsius and the wind speed is measured as 13 kilometers per hour. Okay, so not a bad question. It might look a little confusing, and it's already question 11, so usually a little challenging. But essentially this is actually an input-output question. Here they tell us that when it's negative 40 degrees C outside, we can approximate the wind chill index, W, using this equation. And we have a relationship between W, the wind chill index, and V, which is the wind speed. So on a 40 kilometer, or sorry, not a 40 kilometer, on a day when the air temperature is negative 40 degrees C, we can approximate the wind chill with this function right here, where wind chill and wind speed are related to one another through this kind of relationship. And so what do we have here? We have a day where it's 13 kilometers an hour, that's the wind speed on this day, and it's a negative 40 degree C day in terms of the air temperature. So what do we have? We can just input this value of V, or wind speed, into our equation here, and then we can find W. And no need to get confused about this ln here. Ln is, it's a special type of, it's log base E. But ln, like log, is essentially just a function, just like sine x or cos x. Sine and cosine function are functions. So what do we do with, let's say, sine x, for example? If we put in sine 30, well, we get an output of 1/2. So this as well for ln. If we have ln v, we can input values of v, and then we'll get some kind of corresponding output. So ln, log, sine, cos, tan, these are our functions. and they, in some way, relate inputs that we can feed into them and they'll kind of spit out some corresponding output. And to be honest, for applications interpretations, that's about all you need to know about ln. Okay, so let's go ahead and put this into the calculator. Here we go. So negative 34.1 minus 7.33. Let's go inverse. So the inverse of the exponential is ln. Ln, and then the wind speed on this day was 13. Okay. So there it is. On this day when it's negative 40 degrees in terms of the air temperature and the wind speed is 13 kilometers an hour, it feels like it's negative 52.9. Let's go ahead and write this out. Part A. So remember, this is find. That's the command term here. They're expecting some process and then some solution. So let's write out the equation. Negative 34.1 minus 7.33, and what we substituted into this function, and then the result was that it would feel like negative 52.9 degrees Celsius. Okay, not bad. Let's go on to part B. Due to errors in the measuring device, the percentage error in the approximate wind chill index calculated in part A could be as high as 6%. Predict the maximum and minimum wind chill index for this day. Okay, so we're dealing with percentage error, and we can actually use the formula to solve this, but I think there might be an easier way if we just, I suppose, look at intuition in some sense. So what are they telling us? Due to some kind of measurement error, the value that we have right here, this negative 52.9 degrees C, is not the exact value. It's a deviation, or it could be a deviation, by as much as 6% from the exact value. And so maybe let's just draw some kind of diagram to represent this. So let's imagine this right here, this point, is our exact value. And due to some kind of measuring device, we deviate from this. So if we had absolutely zero kind of measurement error at all, our measurement would correspond exactly with, well, the exact value. We wouldn't have any kind of deviation, but there is some kind of error in our measuring device in this case. And we might be off by as much as 6%. So if this is our exact value due to some measuring device, some measurement error, we could be off by as much as 6%. So this approximate value right here, which we've received, could be a deviation by as much as 6% from the exact. But it's not necessarily only higher, it could also be, well, 6% lower, right? We could deviate, we know we deviate by 6%, but it could be 6% higher or 6% lower. So this approximate value here, this negative 52.9 that we have, could be, well, 6% higher or 6% lower than what the exact value is. And although it might not look like it, we actually have an equation here. So the exact is equal to, our approximate value could be as much as 6% higher than the exact. So our approximate value could be as much as, 6% higher, or 1.06 times whatever the exact is. I think we can do that. That would be maybe a little better. Or the approximate value, I'm going to write it under here, the approximate value could be equal to, if we're 6% lower, like this, we would be 6% less. Remember, 6% less of, the total of 100%. We would have only 94% of what the exact is. And so we have, maybe if we can, what can we do? I guess we could give these variables. We could call this A and E. The approximate value equals, it could be 6% higher than what the exact is, or it could be 6% lower, only 94% of what the exact is. And we know what the approximate value is, so let's actually just fill this in a little more. I'm going to move this down here. That's okay. let's fill this in. We know our approximate value was negative 52.9, and this is 1.06, and this is our exact. I guess we could give this a variable. Let's just call it e, I suppose. And if we wanted to, we could end solve this, or we could just say e and then divide by 1.06. And that would be 52.9 divided by 1.06. In the same way here, if this is negative 52.9, again, let's divide both sides by 0.94 just to get rid of this. And then our exact could be, well, it could be negative 52.9 divided by 0.94, or 52.9, negative 52.9 divided by 1.06. Again, the logic is, if we didn't have any measurement error, we would just get the exact value exactly as it is. But we do have some measurement error, and our approximate value could be as high as 6% above the exact or 6% below the exact. So approximate value is equal to, well, 1.06 times the exact, or the approximate value could be equal to, well, 6% less, or only 94% of whatever the exact is. And that's where we get these equations right here. So let's go into the calculator and work these out. So here's negative 52.9 divided by 1.06. And then we also have negative 52.9, negative 52.9 divided by 0.94. All right, so our value was negative 52.9 right at the beginning, but there could be some measurement error. We could have some deviation. So it could be as warm as negative 49.9, or it could be as cold as negative 56.3, I suppose. So let's go back to the document and write this out. We're asked to find the max and the min. So what could we do? The max temperature, I suppose, would be equal to negative 49.9 degrees C, and the minimum temperature could be as cold as negative 56.3 degrees Celsius. Okay, that is that. All right, just want to show one other method. If you wanted to, let's say, look at something maybe a little more, I guess, using formulas and so. So I'm going to write it out here and make some space. Okay, so we also have the percentage error. Remember, percentage error given by this epsilon is approximate minus exact over exact. And in this case, they told us the percentage error, and then it's also times 100%. They told us in this case that the percentage error was 6%. So in this case, approximate minus exact over exact is equal to 6%. Or if we wanted to, we could even represent this as a decimal. Okay, and what do we know? Well, we know the approximate is negative 52.9, negative 52.9, and then this is our exact, this is our exact, and this is 0.06. And although these absolute value signs which say, hey, no negatives, we just want the absolute kind of deviation from the exact, we actually have an equation here, once again, with just one variable. And this might be a little confusing or a little challenging, because what do we do with these absolute values? The absolute values tell us that, well, we could have a positive. It could be the difference between the exact and the approximation could be greater, it could be lesser, but we only want the absolute kind of deviation. So if whatever's negative in here, doesn't matter if it's negative or positive, we just want the absolute difference between the approximate and the exact. So what does that mean? We can we can take away the absolute values as long as we say, hey, the difference between the approximate and the exact could have been positive or the difference between the approximate and the exact could have been, well, it could have been a negative difference because the absolute values, they take away the positive and the negative, so they kind of obscure it in some sense. We don't know what was there initially. We know that it deviates by 6%, but we don't know if it was 6% higher or lower. So we actually have these two situations, these two equations. And I guess we can end solve. We actually can end solve because it's an equation in terms of one variable, an equation in terms of one variable. And if we do that, we'll get these results right here again. This is a little more formulaic, I suppose, using percentage error definition, saying we have a deviation by 6%. That 6% could have been higher or lower because we have these absolute values which take away the negatives. So put in what we know the approximate, we know the percentage error. Now we've got an equation just with one variable. So I think that might be a little more challenging, but also potentially a little more structured in a way, so whichever way you prefer. All right. Question 12, 9-mark question. An airline restricts the size of bags by stating that the sum of the bag's width, length, and height, ignoring the handle, must not exceed a fixed value of n. And here we have the height, width, length, and they're telling us the combination of width, length, height has to be less than or equal to some value of n. A company is designing a cuboid-shaped bag so that the sum of the bag's width, length, and height equals n. Their design will have a length equal to 3 times its width. As the width of the design varies, its volume changes according to the equation dv over dw equals 690w minus 36w squared, where w is the width in centimeters and v is the volume in cubic centimeters. Part A asks us to use your graphic display calculator to find the value of w that will produce the maximum volume. Okay. So what do we have here? We have, for example, an airline that restricts the size of the bags that people can bring on board. And how do they do that? They tell us that the sum of the dimensions has to be less than some value of n. So an airline says, or not an airline, but a business says, okay, well, people want to bring as much as they can on board a plane. Let's say carry-on, for example. They want to maximize the amount of stuff that they can bring or maximize the volume. What combination of dimensions in this case for a cuboid-shaped bag would maximize the total volume, maximize the stuff or the amount that someone can bring on? And we have a relationship between a change in volume against change in width given by this function right here. So this is a derivative or the gradient function, and it will tell us the change in volume as a function of change in width. What does that mean in practice? It means that for any infinitesimally small increase in w, what happens to the volume? Does the volume increase at that moment, or does it, let's say, decrease? And that depends on the sign of the derivative at that given point. If the sign is positive, we have an increase in volume, and if the sign is negative, then we have a decrease in volume at that point. So let's go ahead and graph this, and I think that will give us some more context. Here we go. Let's go 690. Remember, the calculator is in terms of x, so we got to use x instead of w. 36x squared. There's our function. We can't see it. These are massive or fairly large values compared to our window. Let's zoom out. Actually, let's zoom fit. That's pretty good. I'm going to zoom out just a little more. Okay, here we go. So remember, this isn't volume as a function of width. This is change in volume as a function of change in width. So as we change the width, as we increase the width, what happens to the volume? And so from all of these points, from 1, 2, 3, 4, 5, 6, all the way up to, I'm going to move this, all the way up to this point right here, where we intersect the x-axis, right here, all the way up to here, a change in the width has led to a positive change in volume. That's because the sign of our gradient function, the derivative, which is right here, is itself positive. So we're increasing the volume, increasing the volume. Even though we have a negative slope at this point, it's a negative slope of our gradient function. Our gradient function is still positive at this point, which tells us that the volume is still increasing. So remember, gradient function, slope function tells us the rate of increase. So the rate of increase, yeah, it's going down. A corresponding increase in width doesn't lead to that kind of, increase in volume that it used to. It's giving kind of diminishing returns, but it's still increasing the volume all the way up to this point of 19.167. After that, any increase in width starts to, lower the overall volume. Change in volume is now negative. So what does that mean in practice in terms of finding a maximum? It means that we're going to have an increase in volume all the way to the point of 19.167. That's the width that is going to maximize the volume of this suitcase. So let's go back to the document and write that out. So find the value of W that will produce the maximum volume. W is equal to 19.167, that would be 19.2 centimeters. And this is a find question. For 2 marks, they're going to want some process. So let's just go ahead and I think a sketch is going to be okay. We could also set this equal to 0, this right here equal to 0, and then find the 2 points as well. That would work with NSOLVE. But I think a sketch is equally as good. If I can get a nice quadratic or so. There we go. All right, let's label the coordinate point, and I think it was 19.2, and then of course the y value is 0. All right, so that is our point that maximizes the volume of this suitcase. Okay, let's go on to part B. Show that the maximum volume of the bag to 3 significant figures is 42,200 cubic centimeters. 4-mark question, seems pretty involved. We're already at question 12, so this might be a good challenge. All right, so what do we have? We want to find that the maximum volume, we need to show that the maximum volume is 42,200 centimeters cubed. We know the width, the value at which the suitcase has its maximum volume. So it sounds like if we could just substitute this value, this 19.2, in some function relating both value, volume, and width, then we would be there. Right now we have the derivative function, which is change in volume over change in W. But remember, we have 2 different forms of our derivatives. So we can actually write this. We can write V prime W equals, and then we have this dV over dW. And this might kind of maybe jog your memory in some sense. So we've got the derivative function, and we know in some sense the relationship between a regular function and its derivative. We know, for example, that if we have f of x and we take the derivative, we can get f prime of x, which is a derivative. But we also know that, hey, it's possible to reverse this. This is the derivative, and of this is of course the antiderivative. So if we have, for example, the derivative right here, we can take the antiderivative to get back to that function that relates, in this case, volume to width. Right now we have change in volume over change in width, but we want to find some function that relates volume to width. Because if we can put in this value of width, then we can find the volume at that point. We know this value right here maximizes the volume. Let's put it into some equation relating volume and width, and then we'll get that max volume, or we should hope. So let's go ahead and see what we can do. Okay, so here we go. This is V prime W equals to 690 W minus 36 W squared. And what we want to do is we want to take the antiderivative. We want to find the relationship between V and W. So remember, this is in your formula booklet. This is our derivative, for example. F of x is equal to x to the power of n. And then f prime of x, this is the derivative. This is the antiderivative. What do? We take this n, multiply it out in front, x, and then we have n minus 1, right? And how can we reverse that process? Well, if let's say we have f prime of x, actually let's write it out as, I'm gonna erase this, just so it's not confusing. If we have some derivative, f prime of x, and it's equal to x to the n, how do we get back to f of x? How do we take that antiderivative? Well, we know when we take the derivative, we multiply out in front, and then this exponent is reduced by 1. If we want to reverse that process, what we're going to need to do is we're going to need to increase the exponent by 1. And since when we, again, take the derivative, we multiply out in front, in order to counteract this fact that when we're going to multiply out in front, we don't really want that new constant, or rather coefficient in front. So to counteract that, we want to divide by whatever that new exponent is. And you can always just take the derivative itself and see that you get back to that original function. And you can see if we were to multiply out in front, then these would cancel out. We'd have n plus 1 multiplied out in front divided by n plus 1, and that would just give us back to our original function. So all that being said, let's look at this derivative here and find the antiderivative. So easiest way to do it, I think, is to write out same coefficient, w. W used to be raised to the power of 1. Let's add 1 to it. Now it's raised to the power of 2. And what do we want to do? We want to also divide by 2, just like this. Raise n plus 1, divide by whatever that new exponent is. Minus 36w. W used to be raised to the power of 2, increased by 1. And then what do we also want to do? We want to counteract that by dividing out by whatever that value is, that new exponent. Okay. Remember also that when we take a derivative, right? So let's say we have, I'm going to make up some function. Let's call it p of x. Let's say p of x is equal to like x squared plus 3. And we find the derivative. It would be 2x. And then this constant would just kind of go away. It doesn't influence the rate of change, right? This constant just increases this. It just shifts everything up, or it could shift everything down in other situations, but it doesn't change the slope. So constants just fall away. So when we find the antiderivative, like we did here, we don't actually know if there was some constant. There could have been some kind of constant hanging out here. We don't know, so we actually need to find that out. Let's go ahead and clean this up, and then we'll worry about C. 690 divided by 2 is 345. W squared. 36 divided by 3 is 12. W cubed plus C. Okay. So now, if we could just substitute 19.2 in for W, then we could get the volume, but we still don't know what C is, so we don't yet have a relationship between volume and the width. So what can we do? How can we find this value of C? Usually if we know a point on the line, on our original function, then we can just substitute. That is to say, if we had a V and a W, we could substitute, and we'd just be left with a C, and we could solve for it. In this case, we have to be maybe a little clever or creative to find a point, VW, a combination of W and V, of width and volume. And how can we do that? I think this is kind of, there's a lot of intuition. So I think this is actually a kind of interesting paper and an interesting exam, because we can't, in a lot of ways, actually just apply formulas in a straightforward manner. We need to use some intuition and I would say, yeah, some general intuition here, a little creative problem solving. So what is a combination of W, volume, and width that we have just looking at this bag? We know that it has to be less than some value of n, but we don't know what it is. We can increase the width, I guess infinitely, I suppose, to have some infinitely long bag. so long as the airline is nice enough to allow us to have an infinitely large suitcase. So there doesn't really anything telling us the increase of width. Remember, we're just relating width and volume, so we need to find a combination here. Increasing width doesn't do anything for us. But what about decreasing width? We can't have negative width, but we can decrease the width and make it super, super small when it's just like a tiny, almost like sheet of paper, that kind of thin. This dog is... I hope it stops soon. But anyways, here we have the width. If this width decreases, we can have it like a tiny, tiny sheet of paper, and we could imagine we might not be able to put a lot of, I guess, contents inside this bag. But what happens when we reduce the width all the way to 0? When we reduce the width to 0, we actually just have a plane shape. Plane not as in like plain Jane, but plane as in a two-surface or two-dimensional kind of figure that has no volume. It's just a surface, pure surface. So what we have is volume. When width itself equals 0, volume itself would equal 0. So we can decrease the width all the way up to the point where we can reduce that dimension to 0. And if we take away this dimension, then all we're left with is height and length. And height and length is a two-dimensional figure, and two-dimensional figures would contain no volume. Volume itself is a three-dimensional, what can we say? A three-dimensional concept, I suppose. So we have this combination right here. I should say plane as in ordinary. Plane as in ordinary. Okay. Let me erase this. Okay. So we do have volume. When volume is equal to 0, width is equal to 0. And what does that mean? That means this would go to 0, this would go to 0, and C itself would equal to 0. Let me rearrange that just to make it clear. 0 is equal to C, or C is equal to 0, which means that our function in the end is v of w equals 345 w squared minus 12 w cubed. And that's our function relating volume and width. Last step, let's input this value of w into our function, and then hopefully we get this 42,200. Did a lot of work, so I'm hopeful. V is equal to 345 19.2 squared minus 12 19.2 cubed. Okay, let's go back to the calculator and solve. Here we go. 345 times 19.2 raised to the power of 2 minus 12 19.2 raised to the power of 3, and then it gives us that 42,000 that we were looking for, 42,246. To 3 sig figs would be 42,200. Okay, so let's go back to the document and write that out. 42,246.1 or 42,200, and our units are cubic centimeters. Okay, nice question. I thought that's a good challenge, I think, in a number of ways. There it is. All right. Rounding up this exam here, question 13, another big 9-mark question, and it looks like a bearing question. Bearing questions have become more popular, actually. They didn't actually used to show up so much, and then they showed up all of a sudden, and they've been showing up almost fairly frequently, actually, from that point on. They're becoming more common. And here's another one. So let's work through it. Question 13. Tiki is sailing a boat in the ocean. For the first part of her trip, oops, did I lose functionality on my pen? Oh, let's see what's going on here. Let's see. This is bad luck Tiki question. There we go. All right. Tiki is sailing a boat in the ocean. For the first part of her trip, she plans to start at point A and travel to point B. She then plans to turn and travel 13 kilometers on a bearing of 100 degrees to point C, as shown in the following diagram. Due to navigational error in the first part of the trip, Tiki arrives at point D instead of point B. Point D is 2 kilometers due west of point B. All right. So a few things when we're talking about bearings, just some terminology. Due west is absolute west. So we have cardinal direction of north, east, south, west. Due west means straight west, not, northwest or southwest, but just right west exactly. Due west. We also have a bearing of 100 degrees. What does that mean? That means starting from our cardinal direction, north, true north, we rotate through an angle clockwise, 100 degrees, and then we set off. Okay. Part A, we have 3 parts to this question, and then we have one final question at the end. Part A asks us to determine the size of DBC. DBC. So remember this top hat right here is the angle that we're looking for, and it is, what can we say, circumscribed, I suppose. It is between DBC. This is also a way we might see it, but this top hat tells us the angle that we're looking for, and these are, let's say, the 3 points that make up the angle. DBC. I would say I'm not a big fan of this question in a way, because there's actually 2 different values for DBC. There's this value. This is a legitimate value of DBC, and this is also a legitimate value for DBC. I would say by convention, we find the convex angle. That is to say, the angle that is less than 180. But you might wonder, hey, DBC, there's 2 values, 100 plus 90, or this one right here. By convention, we find the one that is less than 180. All right, but I don't think that's actually all that clear, but there it is. So what is the size of angle DBC? So we're looking for this right here. What is the size of this angle? We know this is 100 degrees. Due west means that this is 90 degrees. Angles at a point sum to 360 degrees. So what do we have? We have DBC plus 100 plus 90. So let's actually just write it out here. 100 plus 90 plus whatever this DBC is, let's just call it X for now, is equal to 360. 190 plus X is equal to 360. And we say, okay, what's that missing piece? Looks like it is 170. And that's what DBC would be. So what is DBC? It is 170. Let's put degrees there. Okay. Next part, they're asking us to determine the distance from point D to point C. So point D to point C. Okay, I'm going to erase some of this and just clear up some space. So point D to point C. What I'm going to do is actually, I'm going to draw that connecting point from DB to DC. Hopefully this works. Whoops. Don't need that. DB to DC. So D to C is this point right here. And it's kind of a skinny shape, but it's actually a triangle. It's actually a triangle. And what do we know within this triangle? Well, we know one side length right here. We know another side length right here. And remember, I think we said this kind of a few times through this exam, a good IB question will often lead into the next. They didn't ask us to find this 170 for, I guess, nothing in some kind of way. We know that this is 170 degrees. So what do we have? We have a triangle. We know 2 side lengths and an angle that is between. and we're looking for this side length right here. I know we called this dBcx above, but I erased it. Now let's call this the distance x. So we have a triangle, two side lengths, and an angle. That suggests that we should use the cosine formula. So where can we write this? Where can we write this? I'm going to try to write it in this space right here, just so we can see this shape as we're going through it. Okay, so we want to find an angle. We have the cosine formula. It's equal to a squared equals b squared plus c squared, a lot like the Pythagorean theorem. But then we have this adjustment right here, 2bc cos a. And remember, these a's are kind of adjoined to one another. This is the side length, and this is the angle that is opposite to that side length. So in that case, this is the side length, and this is the angle that is opposite to that side length. So everything seems to be set up. Let's substitute our values. A squared in this case is an x squared. B squared is 2. C squared is 13. Doesn't matter the order. And we have 2 times 13. And then cos 170. There we go. Let's work this out in the calculator. We could end solve this. Let's go into the calculator. I'm not going to end solve this though. I'm going to do something different. Okay, so I'm going to write out that function. So x squared is equal to all of this business. X squared was equal to 2 squared plus 13 squared minus 2 times 13 times, let's get our trig, minus cos 170. Make sure you're in degree, always a thing to check. Be an unfortunate way to lose mark. So this is what x squared is equal to. 2 squared plus 13 squared, so on, so on, so on. And that's the value, 224. But that's not the distance, right? X squared is equal to all of this, but we don't want x squared, we want x. So what are we going to do? Let's take the square root. There's our square root. Let's go control square root of, how did we get the answer? Man, I forget how to do this on this calculator. I guess we can do this. It's a little clumsy, but there is a way. Here it is. There's our answer. Okay. So, square root of all of this business, we don't want x squared, we just want x. So let's take the square root, and this gives us 14.9736. Okay. So, what is x? X is equal to 14.9736, or 14, actually, it's equal to 15.0. So, going back to the document here, x is equal to 15.0 kilometers. Okay, and that's the answer to part 2. Part 3, determine the bearing Tiki must use to travel directly from point D to point C. Okay, so the bearing that she needs to travel to go from point D to point C. So from point D to point C. Let me erase some of this and just try to write this out. There we are. Okay. Point D to point C. So what is this question asking? I'm going to draw a line here. So this is true north. If I can get it. There we are. This is true north. And the question that they're asking here is, what is the bearing? What angle does Tiki need to sweep through before heading off from D to C? Kind of an interesting question. What can we do? Okay, so think about this just for a sec. I think this is a nice question. Okay, oops, I didn't want to do that. Just erase that one. Okay, so what do we know? Let's put this value that we just found out. We found out that this was equal to approximately 15. Now we have a triangle, and we know what this is as well, 170 degrees. So now we have a triangle, we know all 3 side lengths and an angle, which means that we can find out anything else we want about this triangle. And if we're asked to find the bearing, the angle that we need to sweep through, to go from D to C? Well, we know that this right here is true north. This right here is true north. So these are two parallel lines. And if this is 90 degrees, then this is 90 degrees. Okay. So if we could only find this angle right here, well, then we could say 90 plus theta would give us the total angle that she needs to sweep through. So how can we do that? Well, this theta value here is just an interior angle of a triangle, and we can find that out. Oftentimes, if we have non-right angle trigonometry, we can go through the question of, is it an area question? Is it a cosine? Is it a sine question? We already used the cosine here. Now we have angle, opposite side length, angle, opposite side length. We have everything that we need to perform the sine rule and find this theta value. So let's go ahead and do that. So we want to find theta. Let's say sine theta. Oops. Actually, let's do it this way. Let's write out the sine formula. And that will be okay. So sine A over A is equal to sine B over B. And now let's put in our values. Sine theta over, and what angle, or sorry, what side length is it opposite to? It's opposite to 13. Equals sine B, and you could use any one, but we have these two, this angle and this side length, sine 170 over 15. Now we've got an equation with only one unknown. Let's go ahead and, for this actually I think we can end solve. So going back to the calculator here, menu, algebra, numerical solve. Let's set up an equation. Sine, can we use theta? Let's use sine x. That should be fine. Oops. Need to set up a fraction first. Here we go. Sine x over 13 equals to sine 170. I need to get a fraction again. Over sine 170 over 15. And then what are we trying to solve for? I'm trying to solve for x. All right, there we go. 8.65562. Thereabouts. So what is theta? Let's go back to the document here. So 8.66 degrees, or 8.67 as they're giving it to us if we were to have kept all of our digits. What is the bearing? What is the total? Let's say, what is the total bearing that she needs to sweep through? Well, if this is 90 and this is 8.66, the total bearing that this individual would need to sweep through would be, just to continue this on, say right here, 90 plus 8.66 is equal to, well, 98.66, or what could we have? 98.7 degrees. And that would be the angle that she would need to sweep through. Okay. There we go. There we go. 8.6, 98.7. Okay, good. All right, finishing this up. Due to navigational error in the second part of the trip, Tiki arrives at point E instead of point C. Point E is 2 kilometers due west of point C. Write down the distance between point D and E. Justify your answer. So they told us it's 2 kilometers and it's also due west, which is kind of interesting. So let's first draw the line to show the distance between D and E. There we go. And let's fill in some information that they've given us. So they told us that the distance between C and E is 2 kilometers. And they also told us that it's due west, just like this was. And so if we have two parallel lines here and we're traveling, everything is shifted. Everything is essentially just shifted 2 kilometers. So what we have is a parallel line, and then we have another set of parallel lines here. What we have is a parallelogram. Parallelogram has, yes, 2 parallel and opposite side lengths, and then another set of parallel and opposite side lengths. So this itself must be equal to 13 as well. So write down the distance between D and point E, justify your answer. 2-mark question, it would be enough to say 13 kilometers, and then we could say parallelogram, we could say a little more if we wanted to, I suppose, opposite side lengths. All right, and I think that's it for this exam. All right, great. Hope it was helpful, and as always, best of luck. Take care.